Good day, everyone. This is Mr. Ahmed. Today we're going to cover vector and scalar quantities. We're going to differentiate between vector and scalar quantities, and we will be able to solve questions that are related to vector and scalar quantities. Please, if you've got any questions, write them in the comments below, and I will be happy to answer them. Thank you for watching. Please, if you're new to my channel, please subscribe and follow, so you get more videos related to math and physics. So let's get started with vector and scalar quantities. What do we mean by scalar quantity? When we say scalar quantity, we mean that the quantities or the quantities that have only size or magnitude, but they don't have to have a direction. Vector quantities, they have both size and a direction. Here are some quantities that let's distinguish between them if they are scalar or vector quantities. We've got mass, how the size of an object, or how much particles in it, or how much inertia in it. Is it a scalar or vector? It's a scalar, of course. We don't have to know the direction. We just need to know how much mass is there. Distance, how long something is. It doesn't have to have a direction, so it's a scalar quantity. Acceleration is a vector quantity because an object accelerates in different directions. It could be to the right, could be to the left, could be up, could be down. Wherever acceleration happens, it's a vector quantity. Speed is a scalar quantity. Velocity, that's the difference between speed and velocity. Speed is a scalar, while velocity is a vector quantity. Energy, of course, is a scalar quantity because it just have a magnitude, no need for direction. Time is a scalar as well. Power, scalar. Force, of course, force is a vector quantity because you have to state a direction for forces. Displacement is also a vector quantity. We're gonna have an example of distance and displacement, but this works actually for scalars and vectors in general. But here in this video, we're gonna distinguish between distance and displacement and how we calculate both of them in real situations. How is distance different from displacement? That's a question we're gonna answer. Follow along so that you get answer. Distance is a scalar quantity that refers to how much ground an object has covered during its motion, while displacement is a vector quantity that refers to how far out of a place an object is. It is the object's overall change in position from the starting point to the end point, how much the object has gone. Still confused? Let's see this example so that you can. We said distance is a scalar quantity, so we just need to add the values. For example, Peach goes for a walk around the park, first walking north for 80 meters. He walked to the north for 80 meters, and then turns around and walk 80 meters south. The distance that he has covered would be the total distance, right? 80 plus 80, which is equal to 160. But how far is he from the starting point? If the final distance is 160, the displacement will be different thing, right? We said displacement is a vector quantity, so we need to find the direction too, right? If it goes for 80 meters to the north and then 80 meters back to the south, so how much is covered? It came back again, right? It came back to zero. So how much is it? How much is the displacement? Is 0 meter per second. So how far is it away from the starting point? It's 0 meter. Her final displacement is 0 meter. She's back where she started. Let's have another example. Peach goes for another walk around the park, first walking north for 80 meters. He walks to the north for 80 meter, and then only walks 50 meter south. He's tired. He came back to 50 meters. Now the distance is scalar quantity, so we need to add the values, right? 80 plus 50 is equal to 80 plus 50, which is equal to 130 meters. So the distance, the final distance traveled is 130 meters. But what about displacement? Displacement, we said, is a vector quantity. It starts from this point to it walked to the north for 80 meters, and then it walked back 50 meters in the opposite direction. So what do? These are two different directions, right? So we subtract them from each other. So 80, the displacement would be 80 minus 50, which is equal to 30 meters. That means our final displacement is 30 centimeters. It starts at this point, and our final distance is 30 meters away from the starting point. That is displacement. Very good. Now Peach goes for yet another walk. First she walks north for 40 meters, then turns right and walk for 30 meters. Now this 40 meters, and then to the right it walked for 30 meters. These are two vector quantities that are acting at right angle to each other, right? This is a right angle between them. This works for all of the vector quantities, not just for distance and displacement. The distance, we said, is just adding the total thing. It's 40 plus 30, which is 70 meters. Now what about displacement? Displacement is the distance from the starting point to the end point, right? So if we complete a triangle, this would be the hypotenuse will be the total distance, the total displacement that she walked, right? How can we find the displacement? We need to use Pythagoras theorem, because this is a right angle triangle. Now this is c squared. Displacement squared is equal to 40 squared plus 30 squared. If we consider this right angle triangle, the hypotenuse, of course, squared is equal to 30 squared plus 40 squared, which give us the displacement squared. 40 squared plus 30 squared is equal to 2500 squared, 2500. And if we get the square root for both sides, we get displacement is equal to 50 meter. So the displacement is 50 meter using Pythagoras theorem. Now, what about this angle? How can we find the angle theta? We need to use SOHCAHTOA in order to find that this angle. The sine theta is equal to the opposite divided by the hypotenuse. The opposite of this angle is this one, and the hypotenuse is this one. So the sine theta is equal, and if you want to find the cosine theta, is the adjacent to the angle, which is 40 meter, divided by the hypotenuse, which is 50 meter. And if we want to find the tan theta, which is equal to the opposite divided by the adjacent, this one divided by this one. So let's find sine theta, which is equal to 30 divided by 50. The hypotenuse is 50. 30 divided by 50 is equal to 0.6. If sine theta is equal to 0.6, let's find the sine inverse of theta, which is equal to 37 degrees. That means theta is 37 degrees. So our displacement is 50 meter at an angle of 37 degrees, because we said direction is very important, right? This doesn't work only for displacement, it works for all vectors. There are other ways of finding vectors that act at right angles to each other, but for this video we're gonna stick to this one. Let's solve another question, more complicated question. A man walks around the park, first walking north for 80 meters. Then turning right and walks for 50 meters. He turns right again, and after 10 meter takes a left turn and continues for 70 meter. Now, if you want to find the distance, of course, it's going to be the total 80 plus 50 plus 10 plus 70 is equal to 210 meter. That's the total distance he walked. Now, in order to find the displacement, all we have to do is complete the triangle in order to find the displacement. Now, displacement is the distance from this point to this point, right? Now, if we complete the triangle, the horizontal would be 50 plus 70, right? So this part will equal to 120. That's 120, and this is 80 minus 10, which is equal to 70. So this side is equal to 70, this side is equal to 120. Now we have a complete right angle triangle. We want to find the hypotenuse, which is the displacement, right? So the displacement squared is equal to 120 squared plus 70 squared. Displacement squared is equal to 19,000. If you plug this into the calculator, you will get 19,300. The displacement squared is 19,300. Finding the square root for both sides, we get the displacement is equal to 139. This is 139. Now we'll find the angle. We said in order to find the angle, what do we do? The theta, sine theta, is equal to the opposite divided by the hypotenuse. The opposite is 70 and the hypotenuse is 139. So 70 divided by 139 is equal to 0.5. If you plug this into the calculator, you will get 0.5036. That's sine theta. Now we find the sine inverse. In order to find theta, theta is equal to sine inverse of 0.5036, and that is equal to 30 degrees. So we would say that the displacement is, our final displacement is 139 at an angle of 60 from the north. Now, in order to complete this to the north, that's 60 to the north. And if you want it to the east, you would say it's 30 degrees to the east or 60 degrees to the south. I hope you find this useful. Please, if you find it useful, please subscribe to my channel and click into the bell button in order to get more videos related to math and physics. I hope you enjoyed the class and you understand it very well. If you have any questions, please write them in the comments below, and I will find time to answer those questions in another video. Thank you very much for watching.